In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if any man travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a partner, a family. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Okay, today I'm going to discuss my lecture number 30. Lecture number 30 is basically a recap of petrochemical industry. Okay, so before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me and loose a knot from my tongue that they may understand my saying. Allahumma Rabbi zidni ilma. O Allah, advance me in my knowledge and a true understanding. Thank you very much for your precious time. Okay, oil gas production, introduction, facilities and process, reservoir and wellhead management system, upstream facilities, midstream facilities management system, refining facilities management systems, petrochemicals. Today we are going to recap a petrochemical industry in two sections, part 1 and part 2. Utility systems, unconventional and conventional resources and environment effects. What is the ultimate goal? Shaping the clean and sustainable global energy. Plan to deliver more than 300 lectures next couple of years. Okay, lecture number 30, oil gas productions, recap part number 1. We are going to recap petrochemical product process flow, xylene and polyester chain, toluene, benzenes, polyurethane and phenolic chain, benzene and styrene chain. Okay. Key takeaway points, lecture number 30. So we are going to discuss today xylene, polyester, toluene, benzene, polyester, and polyurethanes, phenolic and benzene styrene chains and their derivatives. Okay, petrochemicals product a process. If we can see here, this is my crude oil stream and this is my natural gas stream. Okay, through crude oil, first we produce naphtha, aromatics, then xylene and polyester chain. And we also produced toluenes and benzene from the aromatics, and we produced polyurethane and phenolic chains from aromatics, toluene and benzene. Okay, from natural gas, we produce condensate, butane, propane, ethane and methane. Okay, further with steam cracking, we produced olefins, and olefins will convert into ethylenes, propylenes and butadienes. And over here, then methane, it will turn into synthesis gases, methanol and ammonia. Okay, petrochemicals are chemicals made from petroleum or natural gas. Primary petrochemicals are divided into 3 groups depending on their chemical structures, as we discussed: olefins, aromatic petrochemical and synthesis gas. Okay, what is the olefins? Olefins include ethylenes, propylene and butadienes. Ethylene and propylenes are important, a source of industrial chemical and plastic products. Butadiene is used in making synthetic rubber. Olefins are produced by cracking, by steam cracking. Okay, number 2 is aromatic petrochemicals include benzene, toluene, xylenes. Benzene is used in manufacturing of dyes and synthetic detergents. Toluene is used in making explosive manufactures are xylene in making plastics and synthetic fibers. Aromatics are produced by reforming. Number 3 is a synthesis gas. Syngas is a mixture of carbon monoxide and hydrogen and is used to make the petrochemical ammonia and methanol. Ammonia is used in making fertilizer and explosive, where methane serves as a source for other chemicals. Okay, as you can see here, this is my feedstock here: crude, natural gas, condensate, butane, propane, ethane, methane, and naphtha. These are my feedstock, and this product is my primary petrochemicals. The primary petrochemicals are not end products, but if you can see from the building blocks, a wide range of material. Therefore, each primary petrochemical gives name to a chain of reactions leading to those material. There are almost 200 petrochemicals that can be discussed in next couple of days. There are more a process than end product, or as each product may require a multiple steps, so an exhaustive list would not fit within these lectures. We can discuss on later stage. We will focus on the main chains of properties and use of the most important compounds and a few key processes for this, as we have demonstrated in the building blocks. Many of these processes are based on polymerizations, which means that it is based on process that first form monomers, then let these binding together to form polymers as long chain or a three-dimensional network. Compound whose names start with poly are generally polymers, but many other are trade names such as naloon, which is a general name for a family of polyamides or polymers. Petrochemicals are often made in clusters of plants in the same area. These plants are often operated by the separate company, and this concept is known as integrated manufacturing process system. Groups of related materials are often used in the adjacent manufacturing plants to use a common infrastructure and minimize our transportations. Okay, this is a continue from the last slide. So this is my primary petrochemicals. This aromatics will produce xylene, toluenes, and benzene. Okay, so the xylene will produce a polyester chain, and toluene will paraxylenes, meta, and orthoxylene. Okay, so the paraxylene will further produce dimethyl terephthalate, purified terephthalic acids, polyethylenes, terephthalate, polyesters of fiber resins, and unsaturated polyester resins, and azophthalic acid produced by the metaxylenes and plasticizers, and then phthalic anhydride produced by the orthoxylenes, and then alkyl resins. Okay, these are component which will be produced from the aromatic, that is xylene and polyester chain. Okay, aromatics are called because of their distinctive perfumed smell or group of the hydrocarbon that includes benzene, toluene, and xylene. These are basic chemicals used as starting material for the wide range of consumer product. Almost all aromatics come from crude oil, although small quantity are made from the coal. Okay, one of the forms of xylene, paraxylene, is used to make polyester, which have application in clothing, packaging, and plastic bottles. The most widely used polyester is polyethylene terephthalate PET, used in lightweight recyclable soft drink bottles. 30% of the production as fibers in clothing, 60% production as filling of, and the diverts in cords of the conveyors belt, etc. It can also be made into film that is used in the video and audio tapes and X-ray, etc. Polyester makes up about 18% of world polymer production and is the third most produced polymer. Polyethylene PE and propylene PP are first and second respectively used. Metaxylene is an isomer of mixed xylene. It is used as an intermediate in the manufacturing of polyesters for coating, ink, reinforced plastic, and packaging applications. Unsaturated polyester is used over a broad spread of industries, mainly the constructions, board, building, automotive, and electric industries. In most applications, they are reinforced with small glass fibers. Hence, these plastics are commonly referred to as glass reinforced plastic GRP, also known. Initially liquid resins becomes solid by cross-linking chains. Accretives or hardening creates a free radicals at unsaturated bonds which propagate in different. Okay, the styrene is often used to lower viscosity and evaporates during hardening, where the cross-linking released heat. Orthoxylene as an isomer of mixed xylate, it is primarily used in plasticizers, primarily in flexible polyvinyl chloride PVC materials to make it more flexible, medicine and dyes, etc. Alkyd resins are a group of sticky synthetic resins used in the protective coating and paints. Okay, from the next slide, we will talk about toluene, benzene, polyurethane, and phenolic chain. Okay, now we're going to discuss toluene, benzene, polyurethane, and phenolic chains. This is continuing from my last slide. So this is my primary petrochemicals. Aromatics will produce a xylene and polyester chain, as I've discussed in my last slide. This is my toluenes, benzene. Toluene will further convert into toluene dicyanate and polyurethane foam, and the benzene will be producing cyclohexanes and cumins, and it will phenol by phenol A, and then phenolic resins, epoxies, and polycarbonates. Okay, the cyclohexane will produce adipic acids and nalone 6 by 6, and it will also react to the corpolactams, and then it will produce nalone 6. Toluene diisocyanate, a TDI, is an isocyanate used in production of polyurethane for flexible foam application, range from furniture, bedding, and carpet underlaying to transport and packaging, etc. TDI is also used in manufacturing of coating, sealants, adhesive, and elastomers. Nalone is a generic designation for the family of synthetic polymer known as generally as aliphatic polyamides, derived from benzene, first produced in 1935 by DuPont. Nalone can be used to form fibers, filaments, bristles, or sheets to manufacture into yarn, fabric, garbage, and it's also conformed into the molded products. Nalone is tough, elastic, and strong. It has high resistance to wear, heat, and chemicals. Okay, it is generally used in form of a fine filament in such article as a horsey and sports equipment and other parachute, but its application also include engineering, plastics for cars, toys, healthcare products, carpets, roller blade wheels, and ship sails, etc. There are many varieties of nalone that have their own characteristic properties. Nalone plastic are used for making such product as combs, brushes, and gears. Nalone yarns, on the other hand, are used for making nalone fabric. When talking about a nalone textile, there are two types that are mostly prevalent in the market: nalone 6 by 6, also known as nalone 6-6, and nalone 6. Phenol is an aromatic alcohol mainly used as an intermediate in organic synthesis. Essentially, it serves as a raw material for the production of biphenyls as a phenolic resins, alkali phenols, and caprolactams. It is a poisonous acidic compounds obtained from coal tar or benzene and used mainly as a disinfectant or antiseptic. Carbolic acids, any hydroxyls derivatives of the benzenes. Phenolic resins are manufactured from phenol. They are used in wood products and molding powders application, and also have the wide range of application on the electrical, mechanical, and decorative markets in the automotive industry. In the building and construction, in thermal insulation products and foundry industry, etc. Epoxy resin is a flexible resin made using phenol and used chiefly in the coating, adhesive, electrical, laminates, and composites for its excellent adhesion, strength, and chemical resistance. Polycarbonates are a particular group of thermoplastic. They are easily worked, molded, and thermoformed. As such, these plastics are very widely used in the modern manufacturing industry. Polycarbonates is becoming more common in housewares as well as laboratories and in industry. It is often used to create protective features, for example, in banks as well as window, roof, wooding, and lighting lessons for many buildings. Okay, Uh, Now we are going to discuss benzene and styrene chain. This is continuing from my last slide. Okay, as we have discussed primary petrochemicals and aromatics. In my first slide, we have discussed polyester chain, toluene, polyurethane chain, and benzenes, phenolic chains, nylon intermediate. Now we're going to discuss ethyl benzenes. It will produce styrene in presence of ethylenes, and then it will styrene butadienes rubbers in presence of butadienes. Okay, so further it will produce a polystyrene, styrenes acrylonitriles, acrylonitriles butadienes styrene. Okay, okay. The polystyrene is a solid plastic made from polymerized styrene. It is a second most common plastic used in a wide variety of everyday applications from coffee cup to CD jumper box. It is a thermoplastic polymer in a solid glazy state at room temperature but flows if heat above 100 degrees Celsius. It becomes solid again when cooled. This allows polystyrenes to be extruded, molded, and vacuum formed in molds with a fine detail and high finish. Okay, the styrene acrylonitriles same is like polystyrenes but offers high thermal resistance and is therefore used mainly in the automotive, electrical, and electronic industry as well as in household application and building products. Acrylonitriles butadiene styrene ABS is a tough, heat-resistant and impact-resistant thermoplastic with the acrylonitriles providing heat resistance and the styrene units offering rigidity. It is widely used for appliances and telephone housings, long sporting helmets, pipe fitting, and automotive parts. Styrene butadiene rubber (SBR) is a rubber manufactured from styrenes because of its excellent abrasion resistance. It is widely used in automobile and truck tires as well as for carpet backing and paper coating. About 50% of car tires is made from SBR. Other applications are in belting, flooring, wire and cable insulation and footwear, etc. Okay, this was my last slide for recap. From the next slide we will conclude and then we will finish our today lecture. Okay, conclusion. We have discussed particular product process flow sheet. We have discussed xylene and polyester chains. We have discussed benzene and styrene chains. We have also discussed toluenes, benzene, polyurethanes, and phenolic chain. Okay, next topic, oil and gas production, olefin products, and its derivatives. Okay, so references, Qatar Petroleum, Doha, Qatar, Oil and Gas Development Corporation Limited, Pakistan, World Energy Outlook 2013, US Geological Survey, US Department of Energy, Schlumberger Oilfield Glossary, International Energy Agency IEA, Wikipedia, Oklahoma State Margins Commission, Pumpers Manuals, State Oil Fact Sheets Nordic Standards Norway, History of Oil in Pennsylvania, Air, Liquid, Gas Encyclopedia, Natural Gas from Wellhead to Burner Tip. Okay, together everyone achieve more. Please do not hesitate to send me your input, feedback, t.masood.dr@pathway.edu. You can also send me your input on WhatsApp as I have provided. Thank you very much. Please stay at home, stay safe, inspired, and blessed. Thank you very much for your patience.